Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
So we now have done, I think, let's quickly have a look at it. 1, 2, 3, 4, 5, 6, 6 or 7 versions of the build-up or area, urban area indices. Each with a unique band combination and equation. But as I said in one of the previous video tutorials, they all seem to focus around the shortwave and the near infrared and the red bands. I think there's 1 or 2 that use green, but it's different combinations of shortwave and red and near infrared combinations. So I think we're getting to the end of it now, of the different indices. Remember, we are referring to this particular article. If you look at the previous video tutorials, this is the one that we're looking at. Okay, and then this particular article, this was done in 2022, 2023, so it's fairly recent. Maybe there's some new ones that have been developed since this article saw the light, but nonetheless, we are working on these indices, creating these ones. There's 1, 2, well, this we haven't done this one. 1, 2, 3, 4, 5, 6, 7. Yeah, 7. So there's 7 of them that we're working on. So the last thing or the last one for this particular series that I'm going to use is what they call let's go back here, is this one here, the build area extraction index. The build area extraction index. Let's just make it a little bit bigger. The build area extraction index. And this again, it used the red one plus 0.3. Don't ask me why the 0.3. We'll have to go to this article here by Bozekri et al. 2015 and go and see why they say 0.3. There must be a specific reason for that. And then they use also the green band. One of very few, you see there's a green band, but that's basically only two indices that use the green band, and they are one of them. And then they use the shortwave infrared one. Most of them, as you can see, uses near infrared, shortwave infrared, and red. Okay, so this is the formula. Red plus 0.3, green plus shortwave infrared. So it's called the build-up extraction index. Okay, build-up extraction index. So we're going to our trusted Earth engine. There's our calculation. So we're going to declare 3 bands. So we're going to declare our shortwave infrared, which is band 11. I'm not going to go to the Sentinel landing page to go and confirm these. You're welcome to, if you want to go and just check it up, you're welcome to go to the landing page, go and have a look. Okay, so there's the shortwave infrared. I've declared that. I've declared the band, the red band, which is band 4, and declared the green band, which is band 3. So there's my 3 bands that I have declared. Okay, then going for my formula. Remember, what's the formula again? The formula is the red plus 0.3 divide by the green plus shortwave infrared. Now, please remember your BOTMAS, okay? Please remember that you must first add the 0.3 to the red and then you divide by this thing, okay? So please remember to use your BOTMAS, okay? And therefore, I've used these commas, brackets, just to make sure that you first add. So it's my red band plus, I'll add 0.3, and I've put that in brackets so that it first executes this calculation and then it divides. Okay, then divide by the green band plus the shortwave infrared. Okay, the green band plus the shortwave infrared. So I'm happy with this formula, and then I call it the build-up extraction index 2024, and I reduce it to my region of interest. Okay, reduce it to my region of interest. Or to calculate the maximum and the minimum values. That mustn't be there. Why am I doing that? That mustn't be there. Sorry. Okay. And then I generate because I'm not too sure about I'm not too sure about the minimum and maximum values, as you're all aware that this is not a normalized index, so the values could be anything. So that's why I use the standard min and max formulas to estimate the ideal minimum and maximum values in my visualization parameters. Okay, so that's that. If we go down, I think it's this one. B, yeah, that's the minimum value, 0.22. You can see there's 0.2. And the maximum value, sorry, there's the maximum value is 0.6, 0.6, just to confirm. Remember, it's based on the scale of 900. And remember, if I go again back to the previous video tutorials, every time you change the scale, the values will change. So just bear that in mind, that the values that you get there is dependent on the scaling factor that you use here. If you use a different scaling factor, you will get different values. And so it's always advisable just to use your inspector just to follow up on these values. It's always advisable to do it. Nonetheless, it's a rule of thumb. It gives you a ballpark number to start working with. It gives you a ballpark number to start working with. And then obviously you play around with your color scheme. Remember, these are bins, and they're normally equally distributed between your minimum value and your maximum. So 0.2 will be white, and a little bit further from 0 to 0.6 will be green, and the orange will be 0.65. So if we want to confirm where our red is, meaning our red is our build-up area, then obviously you'll have to go use your inspector, go to build-up area, and basically figure out what the value there is, and then locate that value within in this range. Okay. So just to confirm, this is called the build-up area index. There's 3 bands. That's a formula for it. Then I generate the minimum and maximum value. I create my color scheme, visualization parameters, and I display it. And that looks something like this. So I get something that looks, come on. Why is it so slow now? That looks something like this. Now again, we have to be honest and say it's struggling to differentiate between build-up areas, urban areas, and bare soil or agricultural land. Because the red here is mostly agricultural land, and it lies fallow or bare during summer. So it's struggling. It's significantly struggling, which is not unique to this, mind you. Most of the other indexes also struggles with it, except the one that we did earlier, which was this one, this band ratio. So far, that was the only one actually that efficiently could differentiate between the two. What I like about this one, however, and this is where I think this one is very useful, is that this one is particularly accurate when it comes to urban areas. And you'll have a look now. I'm just waiting for it to display, and it's struggling. And I don't know why it's struggling. But you can see how this one is, as I said, come on. It's particularly accurate when it comes to the urban areas, in identifying urban areas, more so than any of the other ones. More so of any other ones. So this one, the built-up area extraction index, is precisely what its word says. The title or the name of this particular index actually presents the actual build-up areas very, very well. The name makes sense. So I like this one for that particular reason. I like this one because it is fairly accurate when it comes to the build-up areas. And I said, if you look through all the other indexes, this one is most probably the most accurate when it comes to identifying build-up areas. So it's a pity that it also are so heavily influenced by the bare soils. It's a pity that it's actually also heavily indicating of the bare soils. But as I said, this one, as I said, holds particular value for me. And this is where we need to think now, is we need to use this one, but how are we going to use this? In what way or what matter are we going to use this particular one? And I've got some ideas around this. Okay, so for example, let's quickly show you what I'm meaning when I'm saying it's particularly, you can see if I drill in here, these are also all built-up areas here, but you can see this particular one, and this is the one that I think differentiate the best between build-up and grass. You can see it missed some of the urban. It's quite good still, but if you compare this now to the extraction index, you can see the extraction index in my mind is much more, I don't know why it's taking so much time. It's much more accurate in my mind in, in identifying the urban areas than any of the others. So for example, let's look at the normalized build-up area, for example. You can see how, okay, the visualization parameters are not that ideal, but again, if you compare the two, and it's going very slow, you can see it's much more accurate in identifying the build-up areas. So, as I said, it's a pity that it also struggles to differentiate between the build-up and the bare soils. But that's most probably why it's so accurate in the urban areas, and that's so its benefit lies also in its weakness, if that makes sense. Its benefit also lies in its weakness, and that I think may be what the problem is with this particular one. So if you look at this particular little town here, you can see it's fairly accurate, but yeah, you can see this massive bare soils. So somehow, um, I think we can still use this one. We can still use this one, not in in it per se, not as is per se, but in its benefit to extract the build-up areas. So what we want to do is to see how can we get rid of the weakness of this one, i.e. the bare soils, but keeps its strength, which is the urban areas. How do we do that? Because you can't do it with this index per se. Because as I said, its strength also is its weakness. So somehow what we want to do is to say, okay, we've got this one. Its strength is the extraction, the identification of the build-up area, the extraction of build-up areas. So that is its strength. But how do we get rid of its weakness? How do I subtract from it? Or how do I manipulate this so that I get rid of all this of all this bare soil, so that I sit with only the the urban areas? So meaning we're now looking to create something new. We're looking to create something that doesn't exist. We're trying to see in what combination of indexes, so meaning these indexes, can we use them, meaning these ones, these indexes, can we use them in a combination? So for example, what will happen if I combine this two? Because remember, this one here is efficient in differentiating between urban areas and bare soil. It's not that efficient in identifying the urban areas, but it's efficient in differentiating between urban and bare soil. So that is its strength. But its weakness is it doesn't really extract urban areas that well, or present urban areas that well. So this one's strength is this one's weakness, and this one's weakness is this one's strength. So you see where I'm getting to is, can we now use these two in a combination where by combining them, we're magnifying their benefits and we're eliminating their weaknesses. Think about it. Think about that. Can we use them in such a way that when we use them together, we are excluding or we're eliminating their weaknesses and we are magnifying their benefits? Okay, so let's think about that. So if we use then, let's say we're going to then take this formula, red divided by shortwave minus this part, or should we plus them? And that's what we need to figure out, is in what way are we going to create an optimum solution for this, whereby we use their benefits and we minimize their weaknesses. Okay, because if you look at the two images, so this is the image for the build-up extraction. Remember again, my build-up extraction is fairly good when it comes to extracting urban areas. So that's its main benefit. It's very good in extracting build-up areas, but it's terrible when it comes to differentiate between it. So remember that. On the other hand, this one, the band ratio for build-up areas, is very good, or is okay. Sorry, I'm just waiting for this damn thing to. Is okay. Well, it's better, much better, in differentiating between build-up and bare swells, but it's not so good in extracting build-up areas. So what I want to do is combine these two in some way and form. I think you get an idea what I want to do, or where my thinking is going. And say, okay, has anybody thought of using these ones in combinations rather than using them as standalones? So for example, this build-up index is a combination of two separate indexes. So what I want to see is if we use, let's say, these two, the band ratio for build-up and the build extraction, if we use them in combination. Should we use more in combination? Should we use 3 of them in combinations? So, because each of them have their own little good stuff and bad stuff, you know. So that's what I'm thinking of, because not sure if somebody has done this. But I think we still have to just do these sort of indexes, because what I want to do, if you think about it, we need to find an index now which identifies bare soils but don't identify build-up areas, which we then can use to subtract from the others that doesn't differentiate between. Then we can eliminate the build-up, and what is left? We're only left with the urban areas. So we're thinking of some band combinations here. Index combinations, which hopefully can solve our problems, or hopefully can be better at presenting urban or build-up areas that excludes or that efficiently differentiate between build-up and bare soil. Because that's ultimately what we want to get to, is to say, okay, we want a picture of just build-up areas, irrespective whether you're using winter or summer images, doesn't matter. We want to have an efficient method where, for our region of interest, we can apply a specific index that only extracts, well, only is a, it's I wouldn't go only, but 99% of the time there will be some error. We have to take that as granted, but can do that. Okay, so I hope you have a rough understanding or idea where we're going to. Okay, so do I like the build-up area? No, I don't, because it can't differentiate. It can't efficiently differentiate. Sorry, it can't efficiently differentiate. So do I like it in that way? No. But what I do like is its ability to identify build-up areas. That is what I like. And that's why I won't discard it. And that's why I won't discard it. So just let's quickly go to the article again. So let's have a look and see what this authors conclude in terms of their results. Okay, let me just, sorry, I need to make it a little bit smaller so that all of them are included here. I hope it's still okay. So what they conclude, so there's the different, so there is let's just quickly go to so the build-up extraction is BAEY and the band ratio is BRBA. So it's BRBA. Okay, let me just write it down. BRBA and then the BAEI. So let's have a look and see. So the there's the BRBA. This is the one that is most efficient between differentiating between bare soils and build-up areas. In his region of interest looks like this, and the one that we've just done, the build-up area extraction index, is this one. Okay, so according to him, let's see where they rank. Okay, so according to this, the accuracy assessment. Okay, the accuracy assessment. Let's have a look and see. He says the build, this one here, the BRBA, gives him 91% accuracy. Okay, whereas the NDVI that is 95. But from, let's ignore that for a moment. From the build-up indexes or the urban area indexes, okay, is this one, the band ratio build-up is 91%. Now let's have a look at the BRBI, this one here. So according to him, this one is 91% accurate. This one is 91% accurate. Okay, BRB band ratio, what band ratio for build-up area is 91% accurate, which is followed. Let's see where the BAE sits with the BA. It sits at 74. So it's not, according to him, his one, it's not very accurate. Okay, but in my case, I think it's the numbers looks a little bit different. Anyway, um, we still have to play around with them. I don't think we are done. We've generated the build-up indexes, but there's some other indexes which also indirectly are build-up index, although they're not called build-up indexes. But what they identify specifically is useful for what they're not showing. They're not showing build-up areas. Okay, and so we're going to look at the soil adjusted. You can see there's something there. L is 0.5, near infrared red. You see, we're all working on the near infrared. There's enhanced vegetation. You can see that's when this one uses blue. First one that uses blue. So we're going to quickly run through them as well and have a look at them as well, and then see whether we can use these in some combination of these indexes to better our end result, because in my situation, all of these indexes, and I'm including the band ratio, which is the most accurate, is not very useful by themselves. They are good. They have their own goods and weaknesses, but by themselves, they're not very useless. So that's called the build-up extraction index. It's giving us some ideas to think about, to ponder, as they say, to ponder about. And so let's ponder and think about it, and let's start playing around with that. and see what we can generate. Whether we up to something as for some interest. Okay. So yeah, let's continue with our exploration. Let's continue with our journey. We're really going into uncharted territories. We're going now in something I think which can give us that eureka moment. That gives us, oh yes, oh yes, oh yes, this is how we can do it. Now, from my perspective, it would be wonderful because we're sitting with this dilemma significantly where in other countries, if you don't have bare soils, this is not an issue for you. But from our side, it's a major issue and something that can significantly enhance our understanding of my region of interest if we can figure this one out. So we're gonna in inverted commas fight with this one. We're gonna wrestle with this one until we get something. I think, and whether we going down a rabbit hole here, who knows? Only time will tell. But let's go for it. Let's go for it. We learn as we go along. We learn about Earth Engine. We learn about remote sensing. We learn, we learn, we learn. And that's what we're all about. Okay. Thank you very much for joining me for this video tutorial. Much appreciated. Please remember to like, to like, to like, to subscribe, to subscribe, to subscribe. Press those buttons. Please press them, press them, press them. And I'll see you on the other side.